Good morning. Today we're going over systems of linear inequalities. Basically, we're going to be graphing two kinds of inequalities and figuring out where their shaded zones intersect, if they intersect at all. So some quick explanation. A system of linear inequalities is defined as two or more linear inequalities, linear meaning straight lines. I apologize for my handwriting. That are graphed together. So we're going to be graphing more than one line on the same grid. Second, a solution to a system of linear inequalities is defined as where the solution is the overlapping region of points that satisfies both inequalities. All right, so let me break it down to you, I guess, in basic level. We're going to be graphing two lines that have shaded zones. The solution is going to be where the two shaded zones intersect, if they intersect at all. So I'm going to go ahead, for the purposes of this set of notes, work on the left side with you guys, working along with me, and then you guys will be instructed to do the right side to show me as proof of your understanding. So we will be using the TI Inspire to graph quite a few of these. So let's go ahead and graph number one. Number one, we have two inequalities. We have y is greater than negative x minus 1, and then our second inequality is y is less than x minus 5. Both are in slope-intercept form because they begin with the y. So I can go ahead and get some basic information. For my first inequality up here, the y-intercept is this negative 1. I can go ahead and go to negative 1 on my y-axis and put a point there. Next, my slope is whatever's next to the x. So my slope is a negative 1 over 1, which means down 1 over 1. So I can go ahead and make all the points I need to that satisfy this first linear inequality. All the points that came before and after. Now, based on this inequality symbol, I have a greater than symbol there. Whenever you have greater than or less than by themselves, you will end up connecting with a dashed line. So I connect all these points with a dashed line, not a solid line. That means this dashed line acts as a border between where all my solutions will be found and where my non-solutions will be found. Now let's figure out where I'm going to be graphing. My symbol is read as, my inequality symbol is greater than. That means everything above or greater than my line. So I will go ahead and graph or shade everything up here. I am making my shading zone perpendicular to my line for a reason. You'll see that when I graph the next line. So everything in the shaded zone up to the line is considered a solution for the first inequality. Now I'm going to go ahead and switch up my color and graph my second inequality. Y is less than x minus 5. For my second inequality, the y-intercept is at negative 5. So I'll go down to negative 1, 2, 3, 4, 5, and plot a point. My slope is the amount of x's, or the number in front of x. I have an invisible 1 there, so I have a 1 over 1. So I go up 1 over 1 to continue to find all the whole number of points, solutions to this line. Because this inequality symbol is a less than, just like I mentioned right here, I will have a dashed line also connecting all these points. So I'll go ahead and just fill in the gaps with little dashes. Now I need to figure out where I'm going to shade. I will be shading everything below this line or less than. So I'm going to make all these red lines perpendicular to the line I just graphed. And what you see is I have an intersection point. I have a zone where my red and my blue lines intersect. For those of you who might be colorblind, you're going to see these squares coming up. So my solution zone is everything in this point, in this zone over here. So I'll go ahead and show that by writing a capital letter S to show that that zone only is where all my solutions are. Wherever you have your two colors crossing, that's your solution. All right, let's go ahead and practice this again. Now we'll be using some of the calculator. So number 3. Example number 3 gives us the inequality x minus 4y is less than or equal to negative 24. So let's go ahead and begin with that first inequality, and let's graph it. So to graph it, I'll go to my Inspire. I'm on Scratchpad. If you have anything there, just press Doc B. It'll clear it out. Now I'm going to go ahead and graph everything as a relation because it's just a lot easier and it's my habit. Delete, and I go to 6 for relation. My first inequality is x minus 4y is less than or equal to negative 24. So there's the less than equal to, and it's going to be not negative 24, positive 24. Remember, if you don't know where the inequality symbols are, it's control and equal sign, all right? So there's my first inequality. I'll go ahead and graph that, and here's what I get. What I need is a good starting point. The y-intercept's a great point to get. So I'll go ahead and go to menu 5-1, and it gives me my y-intercept at 0, negative 6. So my first bit of information is that my y-intercept is at negative 6. So I go ahead and go to 0, negative 6, 1, 2, 3, 4, 5, negative 6 on the y-axis, and here's my first point. Now I need any other point on this line. So since I'm already still in the trace mode, I'll go ahead and start scrolling over to the right until I get a nice whole number or half number value that I can graph pretty easily. So I keep scrolling over, I get some decimals. There's some smaller decimals close to a whole number, but I'm going to keep going because I'm counting on somewhere over here to be something that I can use. Well, there's a number I can use, 6 and negative 4.5. So I'm going to use a point at 6 and negative 4.5. That means from the origin, I'm going to go 6 to the right, 1, 2, 3, 4, 5, 6, and then down 4.5 squares. Down 1, 2, 3, 4 whole squares, and then halfway between the next one. So there's my second point. So there's my first bit of data. According to this symbol right here, whenever you have less than equal or greater than equal, whenever you have a half equal sign, you're going to have a solid line connecting everything. So these will be connected with a solid line. You will have a nice solid line because you guys have your ID or a ruler. I, however, am making this on the computer screen, the computer monitor, which is very difficult, so there's the best I can give you guys. So I have a solid line, and according to my graph, everything above it was shaded in. So I'll go ahead and shade everything above my line. So I'll go ahead and make my straight lines. Don't get too carried away because I'm going to have another line on here, and I need to be able to see where the solutions are. So I'm just going to draw a few lines to show my first solution zone. Now to graph my second solution zone, I'll go ahead and do that one in red. I have my second equation down here. This one's in slope-intercept form, so I can just graph it without the calculator. I know that my y-intercept, my b, is at positive 1. So I go to positive 1 and make a point right there. My slope, my m, is at 2, or 2 over 1, or it's not at 2, it is 2, which means I go up 2 squares, right 1, up 2, right 1, up 2, right 1. And I can follow this also in reverse. Back 1, down 2, back 1, down 2. According to my inequality symbol, if it has a half equal sign, then it's going to be a solid line. So I will go ahead and connect this as best as I can with a solid line. Also, just like the first one. Now I have to know where to shade. Well, it says less than or equal to, so it'll be everything below this red line. So everything in this zone here. Now we have all kinds of zones. I have a pure blue zone on the upper left-hand side, a pure red zone beneath this lower blue line. My solution zone is everything that's in here, where the blue and the red intersect, as well as anything on the red or blue lines. Because the red and blue lines are solid, then any point on those lines is also considered to be a solution. All right, as long as it's in the solution zone. Moving on, let's continue to number 5. Number 5, we are given once again another equation. This one's also in a standard form. 4x minus 5y is greater than or equal to negative 35. I'll go ahead, for the sake of example, do both on the same grid this time on the calculator, for those of you who don't know how to do the manual way like I did the second one, the second part for number 3. So that's my calculator. I'll clear everything out with Doc B. So back to my graphing side. Delete. I'm going to graph this as a relation, number 6. My first inequality is 4x minus 5y. Control equals, to get my inequality symbols, is greater than or equal to negative 35. This is my first bit of information. I'll go ahead and get some info. Let's get the y-intercept. Menu 5, 1. And my y-intercept is at 0, 7. So my y-intercept, whoops, let me lock this down. Let's do that. My y-intercept is at 0, 7, or at positive 7. 1, 2, 3, 4, 5, 6, 7 on the y-axis. Now I need any other point, a slope or a point, anything. So since I'm still in trace mode, I'm going to go ahead and just left arrow until I get to a nice either whole number or half number points that I can graph fairly easily. Negative 3 looks good, but I'll just keep going. And let's see where I end up. Maybe I can get the x-intercept, that might help. That would actually be really nice. Let's see if I get down to the x-intercept. Because that would be a really fast and easy point. We'll keep going. It takes forever. 8 3/4, 0. Not quite what I wanted, but I will take it for the sake of this graph. Negative 8.75 and 0. So that means I'm going to go left 1, 2, 3, 4, 5, 6, 7, 8, and a little bit outside, so like right over here. That's fine, because I'm just looking for the general characteristics of this graph. So I have a point at negative 8.5 and 0. I'm sure there's better points I could have picked. I know I'm going to have a solid line, so I'll connect these points with, whoops, a solid line. That is not a solid line. And actually, I think I'm going to erase it and just give it one more shot. If not, then that will just have to stay as is. So let's get this. That's better. So solid line there. I'm going to switch colors up now to represent my second line. Y is greater than negative x minus 2. So I can get the second line on here. Notice that my window is not on the top to write a new equation. To make that happen, I'm going to press menu. 3 for a new graph to enter in. 1 because I'm entering a function. And I'll go ahead and repeat the same process. I'll delete that out. Graph it as a relation, number 6. And then I'm going to type in y is greater than negative x minus 2. Enter. And notice it does its line in red. That's why I've been doing my examples in those two colors. And we can go ahead and get the y-intercept for this line. Menu 5, 1. Now look what pops up first. First of all, it gives me a point in the blue. I don't want any blue points. I want a red point. So I'll go ahead and just press up arrow. And now it goes to a red point. I'm going to go ahead and just go along and trace to the right until I get to a point. So here's a point at negative 6, 4. So I know that I have a y-intercept, not a y-intercept, I just have a point at negative 6, 4. That means left 6, 1, 2, 3, 4, 5, 6, up 4, 1, 2, 3, 4. I do realize right now that I've got to shade in my first graph, so let me go ahead and do that now. According to my calculator, I'm shading everything that was below my blue line. So I should have everything down here shaded. If I continue with the red. There we go. I apologize for that. All right, now back to the red line. So I have a point at 6, 4. All right, that helps me out. Now let's get another point. I need at least one more point. So I'll keep going until I get something nice and even. There we go. At negative 3, 1. So I have another point at negative 3, 1. That's going to be left 3, down 1. Oops, negative 3, positive 1, excuse me, up here. Connect those two with a dash line, because the inequality symbol does not have a half equal sign. So this is going to be a dash line. And according to my graph, I want to shade everything above that red line. So everything up here gets shaded in. Well, is there a space where my red and my blue intersect? And sure enough, there is. That space is where my solution zone is. So my solution zone is going to be above the red dash line and below the blue solid line. So all this over here is my solution zone. All right, moving on, turn your page over to the back side, and we will continue. Whoops, I think that's all my examples. I thought I had some more examples in here. That's all I have for now. So what I'm going to do is go ahead and do the right-hand side examples, and I'll leave you guys with the ones on the back. So going on, number 2, I have y is less than 1/3 x plus 7. So I'll go ahead and begin with what I know. You can graph this if you'd like with your calculator by now, or you can go ahead and do it manually because it's in slope-intercept form. My y-intercept is the plus 7, and my slope is 1/3. And my line is going to be a dashed line. So I go to 1, 2, 3, 4, 5, 6, positive 7. My slope is 1/3, that means up 1 over 3. I can get the points that came before it, but going back 3, down 1. And I know it's going to be a dashed line. I will be shading everything that's less than or below it. So everything down here would be shaded. So basically the entire grid would be shaded. Now I have my second line, which I will do in red. This one says y equals negative x plus 4. The y-intercept is here at positive 4, and the slope is negative 1 over 1. So I go to positive 4, 1, 2, 3, 4. My slope is down 1 over 1. I'll go ahead and look at all the points that came before and after. And now I have to look at this very carefully. I'm going to have a solid line with everything above it shaded. So I'll connect these points with a solid line and shade everything above. So wherever my red and my blue intersect is my solution zone. And that would be in this area here. Moving on to number 4. This one we have a nice interesting little change. So I'll go ahead and start with my very first expression, which is x is less than negative 4. So to graph that, I'll go ahead and use my calculator to show you how that looks, since you guys will be doing most of this on the calculator anyways. So delete relation, x is less than negative 4, enter. So I have a line that goes through negative 4 on the x-axis. That's what this means. So I go negative 1, 2, 3, negative 4. I'm going to make a dashed line because that symbol does not have the little half equal sign underneath it. Now, if I'm on the number line here at negative 4, where do things get less than? That would be to the left. So I'll shade everything to the left. All right, now let's work on my second one. It is in standard form. 3x plus 2y is less than or equal to negative 2. So I'll go ahead and menu 3, 1 to add a new graph. Delete that out. Graph as a relation. 3x plus 2y is less than or equal to negative 2. Enter. Now I need some points. Menu 5, 1. I don't want a blue point. It says relation 1 in blue. I don't want the blue points, so I'll up or down arrow. There, 0, negative 1 is my y-intercept. So I get a y-intercept at 0, negative 1. 0, negative 1's right here. Now I need some other point on that line. Oops. So since I'm still here in my graphing mode, I can go ahead and just start right arrowing or left arrowing until I get to another point. And I have another point. There was one at negative 3, so I can get a better one on the left-hand side. Since I'm kind of happy, since my line exists over there anyways. There we go. At negative 3, comma 3.5. So I have a point at negative 3 and 3.5. So I go left 3, 1, 2, 3, and up 3.5. 1, 2, 3, and I'm halfway in the square. Based on this symbol, I'm going to have a solid line. Based on my calculator's graph, everything below will be shaded. So I'll go ahead and indicate where all my shading will be. And you can see very easily here where the solution zone is. And the solution zone is going to be where I have the red and the blue intersecting. So basically, everything over here is a solution. It can't just be in the red zone. It can't be just in the blue zone. It has to be where the blue and red intersect, if they intersect at all. Now, it is possible to have no intersection, but I believe on these examples, you will have one for every single one that you do. So let's go ahead and get more